We're here in Northbrook, Illinois at UL's Large Fire Lab conducting our full-scale fire experiments for the fire attack study.
This project centers around interior and transitional fire attack, looking at victim survivability in residential structure fires.
Feeling good? Excited? All right. You're in one of the largest fire labs in the world. So what we have behind me is two 1,600 square foot houses that are meant to simulate the average of what you would have in the United States. And we're studying how firefighters fight fire. What we do is we sensor these buildings to make 250 readings in each one of these buildings to understand what is the actual best way to fight a fire. Measuring temperature, heat flux, gas concentrations, all of the things that could possibly kill occupants and also harm firefighters. We're going to burn these houses 30 different times, looking at different methods to attack the fire to give the fire service the input that they're looking for to be more effective, to rescue more people, save more lives.
The first two components of the fire attack study were studying how nozzles entrain air, as well as looking at water mapping to see where water is distributed within a structure. Both hose streams and fires themselves move air throughout structures by pressure differentials which create flow. So if we focus in on the hose streams themselves, we can determine how our water application is affecting fire behavior during suppression operations and can help dictate which tactic to use in a given scenario. Additionally, looking at where water goes within compartments can help us determine where to best direct the nozzle so we can obtain the most reach and coverage while seeing its impact on fire behavior during suppression.
And this will be the second time that we've done experiment 20, and we will be able to compare that to the interior. We'll be able to compare it to one with straight stream, one with smooth bore, one with a fog, one with the stop and move, one with the flow and move. So you can see how all these variables come together so we can paint the full picture. It's all about what's going on, what are the firefighters doing, how is that impacting potential occupants that could be in the house, how is that impacting the fire. We've got our partners from the University of Illinois here. They bring some steam measurement to us.
For the first time, we're able to do some new measurements to quantify the amount of moisture in the air during fires and after suppression using laser measurement systems. The second component that's new for us is trying to quantify the effect of firefighting operations and the fire itself on skin burns for potentially trapped occupants. So we've been able to develop a technique using pig skin to measure the temperatures on the surface and subsurface that allows us to look at burn injury risk as well as heat transfer.
Like all of our earlier projects, this project is increasing the knowledge in the fire service, putting data to tactics that have been used over the decades to better understand how each affects victim survivability in a structure.